In this video, we're going to talk about how to make a custom shell for a 3D part in Fusion 360. Hey everyone, this is Matt with Learn Everything About Design, and in this video we're going to tackle another request that came in. Somebody that's making 3D printed remote control airplanes and was asking about how to make a custom shell where we can add reinforcement ribs in certain directions. So this is an interesting topic because oftentimes when you 3D print a part like this, you're going to end up having essentially the infill and whatever slicer you're using for 3D printing just go ahead and handle all of the material removal and the lattice structure that gets created. However, there are some cases where you might want to include custom features. So what we're going to do is we're going to talk about how we can do that in Fusion 360 with a couple of workarounds and tips. So the first thing is you can go to the description of the video and download this data set if you want to follow along. Really, all it is a profile and it's extruded so we've got a solid body. Now, the first thing that I'm going to do is go into my bodies folder. I'm going to take this body and I'm going to call this one base, just rename it, and I want to create a copy of it. So you can do this by Control C, Control V if you're on a PC. You can right click and do copy, and then I'm just simply going to right click at the top level and paste it. Now, when you're dealing with bodies and not components, then you can copy and paste all day long. They do not maintain a relationship with each other. When you copy components, what you're going to end up having is either a paste or a paste new. The paste new will break the link, or paste will actually keep a link between each component. So now that we have a copy and the original, I'm going to hide the original. And the main reason I wanted to do this is because what I'm going to do is use shell, and I'm also going to use some additional techniques so that way we can build out the inside of this body. So the first thing we're going to do is we're going to select shell, but instead of selecting an individual face like you might normally do, I'm going to select the entire base and determine what that shell thickness is going to be. I'm going to do 2 millimeters and I'm going to say OK. Now, on the surface, it doesn't really look like anything happened, but if we take a look at a section analysis and just drag this through the body, you can see that we've got a thin-walled part. Now, this thin-walled part it's basically the original part, just hollowed out with the inside completely removed. Now, if you're printing this with a powder bed solution or some other method, this is really not going to work because you're going to end up with powder inside of all these areas. If you're printing it on an FDM or an FFF style desktop extrusion printer, then this will probably be fine. It's going to put some supports and infill in there anyways, because it's not going to be able to print these horizontal sections. If this was laying in this orientation, it could print the walls just fine, but once it gets to the top, it's going to be open and it will still have supports in there. That's not really part of what we're doing here, but what we want to talk about is ways in which we can create this inside geometry, and there's a couple different ways that we can do this. One way we can do this is by taking a look at the original copy and subtracting out the shelled version of it. That's going to leave us with just the inside. That's probably the easiest method, but sometimes that doesn't work because you might have complex features. You might actually need to go into your surface tools and create an offset. Now, when you do an offset, and this is not the method we're going to use, when you do an offset, you can select these inside faces, and if they have tangency, it'll be pretty easy, pretty straightforward. And you can select the end as well. We're not going to be able to select the other end, obviously, because of the section analysis, but you can bring it back. You can hold down the left mouse button, and you can find that interface, and then we can say OK. And when we do that, we actually end up with a completely closed volume here, and it's one surface body, but it doesn't really recognize it as a solid because we didn't stitch all these together. Now, you can use the stitch tool and try to stitch them together and turn them into a solid. Sometimes you can use thicken and that'll work as well. So that's one way that we can turn that inside volume into a solid body. Now you can see what we have is we've got this sort of inside section. It's a little bit smaller, and that is the section that we're going to build out our custom features. Let's talk about the other way that we can do this as well, using combine. This is going to require us to make another copy of that original. So again, Control C and Control V. It's going to be kind of hard to keep these in mind. But now what we have is we've got the original and we've got the shelled out version. And what we're going to do is we're going to use combine to subtract one from the other. Now this is something that we need to think about, because which one do we want to subtract? So we want to get rid of we want to use the shelled portion, which was this base here, to subtract the outside. So this is going to be the copy is going to be our tool, and this base piece, I'm sorry, I said that backwards. The copy is going to be our target. The outside full solid piece is going to be our target. And then the part that we're going to use to cut away is the shelled version. We're going to say okay. So again, this leaves us with this inside piece. It should be exactly like the surface version, exactly the same thing. Now, why did I show both of these methods, and keeping in mind that these are not the only two methods? But I showed these because sometimes you have to find a workaround. There are some cases where the surface method is going to be best, especially if you need to make custom features around intricate details. Sometimes the shelled method works just fine. Other times it doesn't, simply because of things like a fillet radius is too tight and the faces disappear and you have problems. So one or the other should work just fine. But now here comes the trick of all of this. Is what we need to do is we need to create the negative space. The part that we actually want is going to be the space that we're removing right now. We have to think in negatives, which is a little tricky to do. So if we take a look at this, the first thing I'm going to do is bring back my base, but I'm going to right click and go to opacity control and just set it at 30% so we can see through it. So now you can see we've got our outside and we've got this sort of inside shelled section. If we hide the shelled section, you can see this part is still solid. And what we're going to be doing is we're going to be turning this inside solid volume into the ribs and sections we want. So I'm going to create a sketch. I'm just going to pick the right plane. I'm going to start with a center point rectangle. I'm going to do this at the origin. It doesn't really need to be this big. And I'm going to sort of exaggerate what we're doing here. So I'm going to add a dimension, D, 15 millimeters. The height doesn't really matter in this case. I'll just make it 150 so it goes all the way through. And the next thing I'm going to do is I'm going to create some additional rectangles. And this time I'm going to use 3-point because I want to create some ribs in the corners here. I'm going to do the same thing over here. I'm not going to spend a ton of time making sure that all of this stuff is dimensioned because you should be able to get the idea from what we're doing. But I am going to add an angle. Here I'm going to say 40 degrees. And this one automatically came in perpendicular. You can see there's a little perpendicular constraint in there, but we can still move around this rectangle however we want. However, I do want to make sure that they are the same on both sides. So I'm just going to click on this dimension to link them together. And they're the same width, they're the same size. You could worry about the orientation, but again, I'm not going to spend too much time on that. Okay, so now that we have these, I'm going to hit E to extrude, and I'm going to take these all the way through, cutting through that body. And now what we're left with are these couple of different pieces. Now what we want to do is we want to go back to the original. We're going to use combine. Again, we're going to use cut. That original is going to be the target, and the tool bodies are going to be all these extra little pieces that we created. When we say okay, what we're left with is the shelled section that has these internal ribs. Now, obviously, this is a simplified example. Now, when I say simplified, what I mean is that you could spend a lot of time making the outside shape much more complex. You could also spend a lot of time having internal details, internal features. Now, the reason that I added these at this stage is because the outside shape was relatively easy to deal with. Now, for example, if you were doing an RC airplane or some sort of fuselage that you had to attach together, more than likely you would have attachment details or features. Now, I would add these after the fact. So I'm going to go ahead, I'm going to put a circle in here, and I'm going to put a small rectangle in here. And what I'm going to do is I'm going to make sure that that rectangle intersects over there. I'm going to make sure that the center of my circle is vertical with the origin. And I'm just going to place this in here as just a sort of a generic key feature. I'm going to hit E to extrude. I'm going to select all the regions that we want to extrude. Let's go ahead and rotate this a little bit. So we want to take this little keyhole feature, and we can take it in as deep as we want to into this part. This part is just extruded, so I could go all the way through. But now what this means is I could have these little key parts that maybe I 3D print that allow me to slide the two halves together. Now, there are always things that we need to think about when 3D printing, things like any support material that's going to be required, whether or not we've got the resolution to print stuff like this. But these key features, if they go all the way through the part, so for example, if I just take this down, or if I say distance through all, that's going to be really easy for us to print. So if this is us looking down on the part, then I don't need any additional support material to make that work. It might be a potentially weak section up here, so you need to think about things like the size of these features. But when we go back to our section analysis, you can see that's right directly in the center of that rib that we made. So we have a shelled part that's lightweight. When we 3D print this, it's going to automatically put some sort of lattice structure or support structure in there to support these horizontal sections when they're getting printed. And these keyhole type features can be a great way to attach a bunch of different parts together. So if you have any questions about this, please let me know. As always, thanks for watching, and we'll see you in the next one.